Here we have sample table which shows sale per date and region. We want to use this data to create pivot table like this, which will show us number of dates when sale was over 75 units, over 53 units, or over 27 units per region and in total. And we also have a slicer to select year for which we want to observe our results. Now, what is the logic behind this calculation? Well, first, for the same day and the same region, we can have several values. So we have to group our values. First, we are going to group them. And for that, we can use, for example, a group by function. We will group all our values per region and order date, and we will sum all of the sales for that region and that date. Then we have to filter this table. We are going to filter only rows where sale is bigger than 75, for example. For that, we just use filter function. And at the end, we want to count those rows. For example, for central region, we want to count these 15 rows. For east region, it would be 7 rows. So these are our final results. And we can get them by grouping again this table by region and counting all the rows for each region. And for that, we can again use group by function. Now, this is the logic behind our calculations. Now, let's see how to create a measure that would give us those results. We go to Power Pivot, and we can create one measure, like this one, that will actually group data, then it will filter everything above 75, and it will count rows in such table. Now, we need 3 such measures. So for 75 measure, for 53 units, and for 27 units. And if we have a lot of data, if we have millions of rows in our database, in our sample table, we will have a problem because each of these measures have the same first step. Now, this first step is expensive. Let's assume that we have millions of rows of data, and we want to group everything by region and date. Now, if we are observing only 2 years, in 2 years we only have 720 dates, and we also have only 3 regions. So this calculation, this will reduce millions of rows to just 2,000 rows. So it is a really expensive calculation, and we are repeating that calculation 3 times. And this will significantly slow down our slicer. So what we can do? Well, would it be possible to create a measure that would return just this table, and then to create 3 measures that would reference that basic measure and would conduct these final calculations? Well, that is not possible because measures cannot return table, they can only return scalars. So that approach is not possible. Instead of that, what we can do, we can actually create a measure that will return all of the 3 values. We will first group our values, then we will calculate each separate value, and then we can combine or concatenate those values in a string. So if we have values 25, 32, and 36, we will combine them in string 25, 32, 36, and then we can create 3 separate measures that will just extract those individual values from this string. And in this case, we only have this step once. And this would significantly increase speed of calculations. Now, this is a valid approach if we want to get text as a final result. But in this case, our final results are actually numbers, and we can combine them in different way. We can actually combine these 3 numbers from which each has only 2 figures into one number that has 6 figures by using a calculation like this. So instead of these 3 numbers, we will have this number, 253,236, and then we can use functions like integer and mod to extract those separate values from this value, and this is the fastest approach that we have used for our pivot table.